Chloe, who is 6 feet tall, casts a shadow that is 9 feet long. At the same exact time of the day, a tree casts a shadow of 45 feet long. How tall is the tree? Now, this is one problem that you will see over and over when we're talking about triangles, right triangles, similar triangles. That is called the shadow problem. Talks about the shadow of objects. Now, at the same time, during the day, the angle of elevation of the sun is gonna be the same if two objects are fairly close to each other, because the sun is so far away from us. The difference in the angle because of the location of two objects on Earth actually is negligible. Now, we know that light travels in straight line, and once it hits the object, that's why there are shadows that are formed. So that's the principle behind this. So sunlight and objects and shadows actually form similar figures. In this case, it's going to be similar triangles. Now let's analyze the figure. There's that picture of the tree, and Chloe standing 6 feet tall. Chloe's shadow is 9 feet. You can see here Chloe is right there, enjoying standing still until Mr. Vallo solves the problem. And the tree with an unknown height casts a shadow of 45 feet. Now the question is how tall is the tree? What I like doing is separating the triangles so that I know that I'm working with two triangles and not just one. So I have a triangle here, and we always assume that an upright object forms a right angle with the ground. And then also we have that Chloe's height right here, and then this object forms a shadow. Chloe also forms a shadow. Now the path of the sun's ray forms the hypotenuse. All right. Now if I may, I will separate these two triangles. So I'll have one bigger triangle. It doesn't have to be exact same size. That's your X. And then the shadow of the big triangle is 45. And then I have another triangle, a smaller triangle, that's Chloe. And I have the shadow, Chloe's height is 6 feet, and her shadow is 9 feet. So this is the tree, and this is Chloe. Chloe. All right, Chloe. Now, I know that I have, since the angle of elevation of the sun is the same, this angle is congruent to this angle. So I have two similar right triangles. So now I can form my proportions. Now, when you form your proportion, the corresponding sides must be proportional. So I will color code my sides right here. This side matches with this side, or height to height. And then shadow to shadow. So you have shadow to shadow. So you have, I can form my proportion as, well, it's gonna be X over 6. My proportion is gonna be X over 6 is equal to, shadow over shadow is gonna be 45 over 9. Now, once I have set up my proportion, I can now do my cross product property. So I always like multiplying by the variable first. 9 times x is 9x is equal to, I'll write it out first, 6 times 45. 6 times 45 is going to be 9x is equal to, 6 times 45 is 270. And then let me divide both sides by 9 so that I can solve for x. It's going to be x is equal to 270 over 9 is 30. So you can see here that the height of the tree is 30 feet. So when you are dealing with the shadow problem, so always make a proportion of shadow, I mean height of an object over height of another object, the length of the shadow of one object over the length of the shadow of the other object. So the height of the tree is 30 feet.